Hi again, Pre-Calc students. Time for another new chapter online, starting with 7.1 today, Basic Trigonometric Identities. So of course you've heard the word identity, and of course that really means who you are. Your identity is who you are. Your role might be different in various settings. You might act differently in different settings, but your identity is definitely who you are. Some people, of course, have secret identities, but in math what we mean by identity, it's an equation. There's the tone. So it's always an equation, but it's true for all values of the variables. So no matter what you put in place of x, no matter what you put in place of theta, that equation is always true. And so in this chapter we'll be working a lot with identities, learning some new identities, and the big thing we're going to be doing is proving identities. And as we'll see, this is not quite the proofs that you did in geometry, a little bit different. The ones we do here are called algebraic proofs. So it's not the statements and the justifications or whatever you called it back in geometry. Basically, we're going to start out with an equation, an alleged identity, and we're going to substitute and simplify. But also there will be times when we will disprove alleged identities. We can do that by a counterexample. A counterexample is simply one instance or one case when this identity does not work. And so you can disprove with one specific example, but keep in mind this is a very important idea right here. You must prove with generalities. You cannot prove anything with one specific example. Now there are several identities that you need to become familiar with. Many of these we've seen already, but then there are a few new ones. Many of these are way on the right third of the back side of your circle graph, but I have included them again here for convenience. Here's the reciprocal identities. And I'll just let you take a look at these and write these down. You may want to pause the video. If you can memorize these, it'll make your life a whole lot easier this chapter, rather than always having to refer back to your trig card to figure out what cotangent is equal to. If you have these memorized, it will save you lots of time and agony and frustration. So again, we've seen all these before, but now in this chapter we're really going to be using them a lot as we substitute them in place of other trig functions. So these are the reciprocal identities and the quotient identities. Here's a few more identities. Now, in class we might expand a little bit more on the Pythagorean one. This one for sure, the Pythagorean identity, this one right here, this one you need to memorize without question, because we'll use that an awful lot certainly in this chapter and even to come, and in subsequent chapters we will. These other two Pythagorean ones are based on this one. Notice if we divided everything here by cosine, that I would actually get this identity. And if I divided everything on my first basic one here by sine, I would get this identity. So these two are just offshoots of the first one. We can show you on the circle chart why this is true. We'll do that in class. And here's another couple ones that are nice. We'll see them even in this lesson. The sine of negative a. Keep in mind that's an angle that drops into the fourth quadrant perhaps, or just the opposite of the angle, is negative sine a. Cosine of negative a is the same as cosine of a. Again, if you can memorize these things, it will help you immensely. I'll always let you use your trig card, your notes, but I'm just saying that the more you memorize, the better off you'll be of these identities. All right, now we're going to look at some examples of how this might work. Here we want to try to prove that this following is not a trig identity by using a counterexample. So all that means is we're just going to put a specific value in place of x and just see if it works out. So let's just say that x would be 30 degrees. All right, so I'll substitute that in there. So then I have the sine of 30 times the tangent of 30, and if this is true, this should equal the cosine of 30. So looking on your circle chart here, we know that the sine of 30 is 1/2. We know that the tangent of 30, tangent is sine over cosine, and so you've written this down on your circle chart along the edge there. And so the tangent of 30 is going to be the square root of 3 over 3. Notice if I do multiply those, I get the square root of 3 over 4 on the left side. Now, if this was an identity, though, it should be true for whatever's on the right side, and so the cosine of 30 we know is the square root of 3 over 2. And when I compare these two values, of course, they are not equal. So we call this a counterexample. We've picked one particular instance, one particular value for x, and have shown that this identity does not work. So you'll be doing that from time to time. Let's take a look at, here's an interesting kind of problem here. Express each value as a trig function of an angle in quadrant 1. So our answer has to be some angle from quadrant 1 here. Now let's think about this a bit. Cosine of 750. So 750, I start here, I go around once, that's 360. I go around twice, that's 720, and then I have 30 more basically. So this is going to end up where 30 degrees is. So this is going to be exactly the same as the cosine of 30 degrees. 30 degrees is in the first quadrant. That's going to have the exact same value as the cosine of 750. All right, so let's try another one here. The next one, the sine of 930. So let's think about that. So going around once is 360, 720, 720, and 180 is 900. And so 930, takes me right about to here. So again, I have that 30-degree reference angle, but notice the sine here, because we are underneath the x-axis, the sine of this is actually going to be negative. In fact, I can just look and see what the value is going to be. I know it's going to be negative 1/2. But how can I write that as something in quadrant 1? Well, I'm going to write it as the sine of 30. That's in quadrant 1. I know the sine of 30 in quadrant 1 is positive. Down here, though, it's negative. So how can I make them equivalent? Simply put a negative sign or an opposite sign in front of sine there. And now it works, because the sine of 30 is 1/2. The sine of 930 would be negative 1/2. Well, the opposite of 1/2 is obviously negative 1/2, so now it's equivalent. That's a little screwy, but I think looking at the circle chart, maybe drawing it out, visualizing it should help you quite a bit. The last slide here, these are the kind of things we'll be working on quite a bit. It says to simplify this expression. Now notice that this is not an identity. It's not an equation. There's no equal sign there. But we just want to see if we can simplify this a little bit. So remember, the key strategy for simplifying is just to try to substitute things and then maybe we can do some simplifying there so it boils down into something a little bit easier. All right, so let's see what we can do here. I know that cosecant is 1 over sine. By the way, there's no one right or wrong way to do these problems. Sometimes you'll start down a path and it won't be quite right and you'll just have to start over. By the way, I don't like that green on here very much. I think I'm going to start over with that in some different color here that I can see. How about brown? Okay, so we got 1 over sine of x. Now, cosecant, or cotangent, is cosine over sine. So I'm going to do this. I'm going to leave that as the cosine of x. I'm going to write the cotangent as cosine over sine. By the way, this is supposed to be a multiplying sign there. And what that helps me with is now I have a common denominator on each of these things. So what I'm going to have is 1 minus cosine squared. Cosine times cosine is cosine squared. That's how I write that. and I'm going to have a common denominator of sine of x. So I can combine those together. Now, here's where knowledge of the Pythagorean identities can help you a bit. Right here, 1 minus cosine squared, that's the same as sine squared. That's kind of manipulating around one of the Pythagorean identities. And sine squared over sine, that's kind of like x squared over x. One of the signs will cancel out, and this simplifies down to just the sine of x. We'll be doing a lot of problems like this, and so you really got to buckle down and go for it on those. They're not super easy to be sure, but once you do a few of them, you'll get in the swing of things, how they work. All right, thanks for listening, everybody, and we'll see you guys in class.